Hello and a warm welcome to today's online panel session. My name is Andrew Wade. I'm the features editor for The Engineer, and I'll be your host today for the latest in our series of online sessions where we take a look at some of the most important topics and trends impacting the world of engineering. Today's session is titled Getting Product Development Right and is brought to you in partnership with process optimization specialist QRA. At a time of rapid change, the pressures on the product development cycle have arguably never been greater, and delivering products that align with the original design intent never more important. Small errors at the beginning of a design process often become amplified as the development cycle moves forward. And in a world of increasing product and system complexity, it's vital for engineering organizations to mitigate against these risks. To shed some light on the issue, we're joined by a panel of experts from across several different key engineering sectors. The format today will see each speaker give a brief introductory statement relating to their particular sector. Once we've got through those opening statements, we'll kick off a Q&A session. Our online audience can submit their questions throughout the session. We do have a hard stop at the end of the hour, but we'll try and get through as many questions as possible before time catches up with us. So without further ado, I'd like to quickly welcome and introduce our panelists for today. I know one or two of them were having some technical issues, but hopefully they are all with us. First up will be Jordan Kyriakides, co-founder and CEO of QRA. Jordan is an internationally published scientist with a background in quantum theory. Having spent more than a decade in academia and research, he founded QRA in 2012 and now spearheads the company in its mission to de-risk complex product development projects. Next up will be Luke Hares, founder and chief technical officer at CMR Surgical. Over more than 20 years, Luke has been involved in the development of numerous products and medical devices, including the groundbreaking Versius robot that has helped revolutionize minimal access surgery. Luke will then be followed by Alex Loudon, Senior Technology Acceleration Manager at the Offshore Renewable Energy Catapult. Based in Glasgow, Alex is responsible for the ORE Catapult's work with SMEs and startups, and is currently being kept busy with the ScotWind project that should see up to 10 gigawatts of wind capacity installed off the Scottish coast in the next decade. Next up, hopefully, if we can overcome some technical issues, will be Conor McCarthy, an Associate Director for WSP in the UK. Conor is an experienced civil engineer and project manager, having delivered a wide range of infrastructure and highways projects across public and private sectors within Ireland, the UK and Australia over the last 18 years. And then finally, we'll be hearing from Simon Blake, Director of Products and Concepts at Bentley Motors. A fellow of IMechE, Simon has a wealth of experience in automotive design and has a fundamental role in guiding the direction of the storied Bentley brand as it pivots towards an electric future. So that's the introductions over. A really strong mix of speakers with different backgrounds that should hopefully give us a well-rounded picture of this increasingly important topic. A gentle reminder to our audience that you can submit questions to our panel via the online chat box throughout the session. We'll get through as many of those as possible before our 3 p.m. finish. So we're going to kick things off by asking Jordan Kyriakides to set the scene for us. Jordan, can you tell us a little bit about why this is such an important topic and some of the work that QRA is doing?
Thank you, Andrew. Very much appreciate that introduction. And I'm going to start with a story. One of our early customers is an energy company. They told us a story once that changed how we view the role of text and requirements in large-scale systems engineering. They had a large offshore platform, and they brought in a piece of equipment that was to go on the drill at the bottom of the sea. Now, this is a harsh environment, remote, and it's not easy to deliver equipment. It turned out that this one piece of equipment was the wrong size. It didn't fit. The entire operation had to stop while the problem was diagnosed and the solution vetted. In the end, a new piece had to be built and shipped. All in all, this one mistake compounded into an 18-month production delay, millions of dollars in rework, and in lost production. But everything was built and delivered according to spec. The problem was that the requirements were wrong. And with such a large operation, it's just not possible for humans to read, understand, and verify everything. One mistake in language can cause expensive product rework, delayed or missed revenue opportunities, and potential product liability and personal injury. The world's technical information is largely encoded in text. These types of problems, seemingly minor, innocuous language, lack of clarity, lack of consistency, ambiguities, these are the source of almost 50% of all errors in systems engineering, the root cause of the errors. There is a huge need to solve these problems. In principle, these types of problems can be eliminated by technology just recently developed in AI and natural language processing especially. But in practice, a great deal of work remains to be done. And if we look at the macro trends, the problem can get much worse. Product design and build and test are all being automated. As the human recedes from this cycle, the iterations will increase in frequency by over 1,000x. And as products and systems become more complex, we just cannot spec everything out up front. How can we ensure we get the product we need when we don't even know what we need in great detail, especially early on, and when we are deploying autonomous agents that are able to process information much faster than humans and who can now act on the world and execute cycles of design, build, test, and learn without explicit human input? We're not quite there yet, but that is the direction in which we're going. So whether it's human intent in all this, like in previous strategic inflection points, and we're definitely in one now, the human moves earlier in the process and higher in level. The role of the human now is becoming to discover and refine the intent. What do we want? Why do we want it? What is mandatory and what is prohibited? We need intent-driven development. Autonomous agents ought to have the agency to do what they do best, and humans to do what they do best. Guide the development through intelligently refining the intent. The specs, requirements, the mandatory and the prohibited, these all evolve as the project evolves. And QRA's mission is to bring about this change successfully. We have 3 guiding principles. 1, to create objective measures of requirements quality. Today, people want to make sure the words people write down accurately convey what they want to say. Clear, concise, atomic requirements, especially technical requirements. Consistent in style and in terminology. Free of contradiction and redundancy. Compliant with both company guidelines and accepted best practices. Number 2, we want to ease the burden of manual processes. Best practices are evolving, and this is placing additional burdens on manual processes. It is especially taxing on the most senior engineers. Too many high-value engineers are engaged in low-level drudgery, and we want to ease this burden. And number 3, we need to integrate with existing workflows and tools. It is not enough to just solve the problem. It must also be delivered in a way that is usable. Isolated islands are bad. Vendor lock-in is bad. Requirements quality can be measured automatically. The product we have in market today is QV Scribe, and a core use case is measuring the quality of requirements. We evaluate against 16 distinct problem types. We measure each and every one of your requirements against these problem types, and we produce a score from 1 to 5 for each one of your requirements. As you edit the requirement, you see the score change. You know what to fix, how to fix, and why you should fix it. And the benefits compound as you go from authoring to the dreaded review meeting. A boardroom full, or a Zoom grid these days, full of highly qualified and expensive engineers quibbling over the meaning or syntax of a singular requirement. This is soul crushing. Too many engineers, too many high-value personnel in general are engaged in low-level drudgery, and the review meeting is the archetype of this modern-day illness. What we need to do is elevate the discussion in review meetings to the content of the requirements. Is this the correct thing to build, rather than the structure, syntax, or meaning of a requirement? Before QV Scribe, people were reviewing requirements manually, usually with a highly experienced engineer. But with some projects having over 10,000 requirements, it is simply not possible to review them all. So they resort to a statistical sampling. They sample requirements and they hope for the best. This does not, and in fact cannot work, and here's why. If a very small number of requirements are responsible for almost all future problems in development, then going deep on a few requirements is a bad strategy. Instead, going broad on all requirements is a much better strategy. Automation like QV Scribe enables the analysis of every requirement in your corpus. This is much better even if the analysis is less robust than human eyes. But in many cases, the analysis is better than human eyes, especially if you're reading requirement number 5072 and you're only halfway through. There's a new field called requirements engineering, and it is relatively new discipline, and many companies are investing in it. Societies like INCOSE and IEEE, they're publishing guidelines on the elicitation, authoring, and development of requirements, but implementing these guidelines, really well thought out recommendations, are placing burdens on our customers because there are no good tools to assist them. We can help to specify the structure of a requirement whenever appropriate, automate best practices whenever possible, and provide guidance whenever needed. People learn best when the information is provided when they most need it, when they are actually in their day jobs, fingers poised over the keyboard, banging out the specs. That's the time to deliver short, hyper-localized lessons, hyper-relevant to what they're doing right there, right then. We can integrate the learning right into the day-to-day work within their existing workflow. And finally, many companies use many different tools for the same thing. So cross-platform capabilities and integrating them with multiple tools is important. In fact, it is a key differentiator for us. One example, an OEM might use Doors, a large, expensive beast of a product, but their supplier might use Excel. With Cubescribe, they can each use their own workflows and tool set, but still integrate with Cubescribe. Our customers hate vendor lock-in. We provide a way to mitigate that risk. That's basically the end of my story. I just wanted to tell everybody or demonstrate to everybody how the autonomous systems that we have now and are coming online now really act much faster than humans in ways really we do not and cannot understand today. And in the future will be less so because they go so quickly. Technology helps keep humans in the loop and above the fray, guiding with intention and purpose to build the product that you want. And I also mentioned about the ways we're going about our principles to provide objective measures of requirements quality, to ease the burden of manual processes, and to integrate with existing workflows. Thank you for the time. I will now hand it off to the other speakers to hear how they are handling this, how are they handling this issue in their own companies. Back to you, Andrew.
Many thanks for that, Jordan. A really good overview of the topic and what QRA does. And we move on now to Luke from CMR Surgical. Having worked in the development of a hugely complex project like Versius, Luke is certainly well positioned to add to the conversation. Luke, over to you.
Hello there. Right. There may or may not be a slide. There is. Hooray. Right. Hello, everyone. My name is Luke Hares. I am the CTO and co-founder of a company called CMR Surgical. We have developed, built, and are now selling a medical device called the Versius surgical robot. It is a telepresence system for doing laparoscopic surgical robotics. I think it's worth just providing a little context before I sort of speak to the specific point, which is, how you align that original design intent with your product development process. A surgical robot is a very complex device, and it might sound obvious, but you have to get all of it right. Its entire functionality lives on all of it being tightly optimized, and therefore keeping the design team very well aligned with what you're trying to achieve whilst they are diving into the detail and down their little rabbit holes to fix their particular bit is extremely important. Given that, I think it's probably worth just expressing, the original design intent for Versius, which is, what an important thing to understand about CMR is that we're incidentally a robotics company. The big problem we're trying to solve is that laparoscopic surgery is medically very beneficial for the vast majority of people, certainly compared to open surgery, but there aren't nearly enough laparoscopic procedures done. Uptake is about 50%. The reason for that is it's very difficult to do. We wanted to give surgeons a better tool. So our original design intent is to provide surgeons with a better tool for doing laparoscopic surgery. And then we broke it down a bit. And what does that mean? Well, it means it's got to be versatile. It's got to do everything. It's got to be easy to adopt. It's got to fit into existing spaces and OR workflows. It's got to be easy to learn how to use, both for surgeons and for the bedside staff. If you can achieve that, you've got a system that can do everything, and there's lots of people who can drive it, both by the bedside and as surgeons, then suddenly you've got a system you can keep busy. You can get the daily utilization to 3 or 4 a day, which is the same as a reasonably busy OR. If you can do that, you can completely transform the economics of providing it, and that brings the cost per procedure to within roughly the same cost as a manual laparoscopic procedure. At that point, everyone can have one, which is what we're trying to achieve. That's the design intent, and everything in the design needs to align with that intent. How do you do that? We start off with a small team. I now have a department with a couple of hundred people in. We still need to maintain that design intent, that understanding. So the key to us doing it was, first of all, to develop an extremely strong product vision. We, broadly speaking, know what Versius needs to look like. It needs to provide 3D vision. It needs to do all the frame of reference transformations. So when the surgeon moves their hands up, down, left, right, they see the instrument tips as they're looking at them go up, down, left, right. The robotic system handles all those frame of reference transformations. It mustn't be big. It's got to be able to fit around the patient. You've got to not lose track of any of those things as you're going through the development process. So create that vision, maintain that vision, learn to draw. I mean, for something like Versius, it really helps if the entire team have got a clear picture of them in their mind as to all the design features, all the design elements, and why they are the way they are. It doesn't matter, that they're software engineers. They need to understand, roughly speaking, why the mechanics is the way it is, and vice versa. And so that comes down to communication. And I think this is probably the last point I'll make. Design intent is an idea. The development process that you're going through, that's something people do, and as they do, they work on their bit, they dive down their particular rabbit hole. Actually, the key to keeping your development processes, the output of that development process, aligned with the original design intent, is getting it into the minds of the development team. A surgical robot's quite a big job. It's nothing like as big a job as an oil rig or anything like that. The team is initially dozens. It's not hundreds. It's not thousands. That enables us to be reasonably small, reasonably tight, reasonably fast. But what sounds like a technical problem, I would argue, is actually a people problem. It's a leadership problem. And it's ultimately about ensuring that there is a clear vision that meets the design intent that is understood by the whole design team. At that point, I look forward to our discussion later, and I'll hand off to the next speaker.
Thank you very much for that, Luke. Next up, we have we're going to get some insight on the energy sector, and in particular the rapidly evolving area of offshore renewables. Alex Loudon from the Offshore Catapult. Over to you, sir.
Am I coming through okay, Andrew? Sorry, my screen has frozen at the wrong time.
Yeah, you're coming through. We can see you.
Okay, perfect. So yeah, thanks very much for asking me along today. And so our Catapult's job is to accelerate product development and commercialization for the offshore renewable energy sector. So I want to talk from the perspective of an organization who helps companies with their own product development. We don't necessarily do it ourselves. It's about supporting others to do it better and to do it faster. And so I'm just going to talk around 3 or 4 things that I've come across when working with particularly small businesses, SMEs, in their product development for the offshore renewables industry. And the first thing is getting the right requirements. So I think requirements has been talked about quite a lot already. But how do you go about finding those requirements and understanding them fully in quite a complex industry that's maturing and changing all the time? And I think a lot of companies that we work with have, honestly, a bit of a lack of understanding as to who actually knows what the requirements for their product might be. So people often think of the wind farm operators as the kind of panacea, the go-to organizations to understand those requirements. However, whilst they own and operate the wind farms, they might not be the right people to speak to. Which parts of the supply chain actually have interest in the product that you're developing? Who is the economic buyer? Who's the product user? Who's the product owner? And they're not always the same person. So you might actually be speaking to the owner operator to understand requirements, but the person who will be deploying your product could be 3 or 4 tiers down the supply chain as a contractor to an EPC package owner who is then supplying the wind farm owner. So getting that right is incredibly important. Secondly, we do a lot of testing at our Catapult, and testing, as I'm sure you all know, is a really, really important part of product development. And sometimes the testing that you need to do is super obvious. So for example, if you're developing a new wind turbine blade, you need to get a type certification, which has a clear test specification that is written down and is standard. But if that's not the case, are you doing the right kind of testing? And what are you looking to achieve with that testing? Is it to collect data on how your product performs? Is it to gain confidence that your product does the right thing? Or is it to tick the box of a customer? And testing can be very, very expensive. So it's worth asking yourself, is that test really necessary? Or would a smaller test be more suitable? We work with an awful lot of companies who, in their projects, they might specify a 2-day demonstration at an operational wind turbine at the end of their project, and that is seen as the be-all and end-all. But there's no stepping stones to get to that point, which makes that test incredibly risky. And I think sometimes it's important to take a step back and think, would 20 days of testing at a smaller scale, perhaps not quite as realistic, but 20 days is, you might be able to do 20 days of it as opposed to 2 days at an operational turbine. Would you get more value out of that less realistic but longer duration test? Jordan already spoke about the growth of robotics and AI, and within the offshore wind sector, this is something that we're seeing as well. The use of robotics in operational situations to do inspections and sometimes even maintenance and repair tasks, I think provides a kind of unique set of challenges for product development. Robotics are a kind of unique combination of hardware and software, which really takes the complexity to the next level. So you might need to change your approach from if you were simply developing a piece of hardware as a product, where you might follow a kind of waterfall project methodology. Do you need to be more agile to incorporate the software sides? And testing, again, is a really important part of this, because you might need to use virtual environments to do that testing, because it's really difficult to prove that an autonomous agent does what it says it will do. And so it's important to do lots of testing to feedback and iterate on your product as you move along. And I think treating testing as a key part of the product development can greatly increase the chances of building a successful product that that customers can have faith in, and for the risk profile of adoption to be low enough to make it worthwhile. And the last comment I just want to make is that product development is clearly important, but it's important to get everything else right as well. And what I mean by that is that a number of companies that we work with are really quite small. There might be teams of 5 or 10 people, and designing the right product and getting that product development process right is clearly important. But it's no good if you design the right product, but then nobody's able to buy it because you haven't managed to secure investment and scale up, or because you haven't managed to engage with customers and build a sales pipeline, or because you've ignored other commercial work, and so your business isn't able to maintain its momentum. And so getting product development right is crucial, but it's one piece of a puzzle of building a successful business. And therefore, don't ignore everything else, would be my closing remark. So looking forward to joining the Q&A in a few minutes, and over to the next speaker.
Many thanks, Alex, for that. Just a reminder to audience about the Q&A as well. You are able to submit questions throughout the session via the Q&A tab in the chat box on the right of your screens. And we go now, hopefully, to Conor McCarthy from WSP. Conor was having some technical difficulties, but I do believe he has audio and should be able to give us his presentation via that. We're going to check that out. Check that out now. Hopefully, Conor is going to be able to fill us in on the impact. How some of these issues are impacting the built environment and the civil sector. Conor, are you there? Are you able to join us? Conor? Sounds like Conor might still be having some technical difficulties. So instead of going to Conor, we're going to go to Simon Blake from Bentley. Last but not least, we have Simon Blake. Simon Blake from Bentley, an iconic British motoring brand in an industry facing big product design challenges. around issues such as electrification and autonomy. Simon, many thanks for joining us. It's over to you.
Thanks, Andrew, and welcome everybody. So yeah, how does this topic affect Bentley? So Bentley, we're the world's leading luxury car manufacturer based in the UK, north of England, and our heritage for 100 years has been performance, comfort, refinement, wood, leather, engines, and unparalleled craftsmanship. You might say that could be irrelevant for the world in the future. So let's just have a look at a couple of slides to set the context. Here we go. You should see this. So what are the key challenges we face right now as a company? So electrification and autonomy, well, it's the path the sector's going down, isn't it? And how do we connect our customers to that journey? Do they want electric cars? Is charging a luxury experience? Do they want to be driven, or do they want to drive themselves? The requirements of classic luxury, they're very different to modern luxury. So what does that mean, and how does it affect product development and services, not just in the car and outside the car now? Customer demographics change, luxury is accessible to more and more people, and trends change faster and faster. Do people want top speed and power anymore, or are they more interested in connectivity? Cybersecurity is the talk of the town in the automotive industry right now, and associated legislative deadlines drive major changes in software and services. Now, this isn't a field of expertise historically at Bentley, so how do we learn these skills and knowledge at the same time as remaining best in class in more traditional hardware-orientated attributes? Competitors and significantly successful startups, or I call them disruptors, are changing the pace of what we do and develop. And larger OEMs like ourselves need to be more agile. We need to find new solutions to compete in order to bring that product to market faster, but also in a way that still continues to excite our customers. So how do I solve that problem? It's quite an intensive time to be part of the automotive sector. So firstly, I think Jordan mentioned it, redefine the vision for the brand. That's been key. Set new targets. What are the emotional USPs or the selling points we want to consider in the world of emerging pressures and customer expectations? Being relevant, being fast. This takes time and is critical to success. It must be agreed with all the relevant stakeholders across the business. No longer is a car company run by engineers. It's run by all equal partners in the business. What will a customer use a car for in the future? It's more than just a method, surely, of getting from A to B. We have the opportunity of using the time that that customer invests in the luxury product to do something valuable and innovative within it. So innovation is a game changer here. So what are the tools for innovation? Surely the car can learn from you and make decisions for you. Think about that in the context of automotive health. Moving from traditional switches and displays to something completely new and innovative. So once we understand these customer requirements and customer journeys and use cases, we can start to define the requirements. We've heard of that already, but define them accurately and stand by them. And this highlights where gaps in capabilities and skills really are, which leads inevitably in our company right now to a huge skills transformation. It's massive. The development of complex product is a team sport, and in every single review bar none, all business areas are represented. An engineer never develops in isolation in the automotive sector anymore. Marketing, production, purchase, finance, they're always in every review, making sure the requirements are adhered to. We use systems engineering, so you could argue we're very, very, very late to the party with systems engineering. It's been used for decades in other industries. We've never really needed it before, but we certainly do now to provide the methodology and the processes to get the product right from the start and manage that huge complexity throughout its development. We will not succeed developing a software complex product using old historical methods. And embracing that change curve and behaviors is a key solution. It's a cultural solution. Large investments in cutting edge digital tools, including virtual reality, augmented reality, mixed reality, they are commonplace now in my daily work to accelerate design and development at the front end and minimize the need for producing physical hardware. It's not good for the environment, it's not good for pace, and it certainly isn't good for the expenditure. It provides an exciting opportunity for new engineers, processes, and more importantly, thinking. So these are just a selection of insights to how we can solve the problems. And finally, this is a very, very, very simplified schematic of systems engineering, but just to reinforce the point, the philosophy is all about putting the energy at the start, the very top of this V model. What are the requirements? What do you want to make sure it all happens and interacts as a physical, a logical, and a functional architecture? Then essentially, before you actually design and develop any solutions to something you might not actually know you need, invest the time to define exactly what it is you want and how it should work together with hardware, software to get it out of the car. Then you start to develop and solve the problems, find the solutions and create the product. And then to ensure it all comes together correctly, interfacing correctly, inside and outside the car with connected services, you validate it at the very end against the clear requirements you set right at the start. In this case, it's 4 years to design and develop a car. And using those innovative tools and techniques to minimize the need for physical prototypes. So thank you for listening, and I hope this gives you a very quick insight into our world of how we're going to electrify our products by 2030 in a complex space with accelerated purpose against a backdrop of ever-changing technologies, innovation, and pace. Thank you very much. Back to you, Andrew.
Many thanks for that, Simon, and indeed thanks to all of our panelists for their presentations. We move on now to the Q&A. Questions have been coming in, although they've been coming in slowly. So a reminder to our audience that they can use the Q&A panel on the right of their screens beside the chat button to continue to submit questions.
Andrew,
we do have a couple.
Want to check if you can hear me?
Yeah, Connor. Yes.
Connor.
Would you like to?
I've been able
Connor,
to
do you want to
do through the phone?
Yeah. Do you want to present, Connor, or should we just dive into the Q&A and then you can contribute via that, or would you like to go through your presentation?
Happy to. If you can share the slides that I sent through earlier, Andrew, then yep, happy to present.
Yeah, I think if we can, Angie might be able to help us in the background here with Connor's slides. Angie, if you're in the background, can you see if we can get Connor's slides up so that Connor can present?
Brilliant, thank you.
Great stuff, thank you. Yeah, I think we'll drop off now and we'll let you go ahead, Connor.
Thanks, Andrew. So thank you everyone today for firstly Andrew for inviting me along, but also for being here to have a little discussion and hear from a civil infrastructure perspective. So next slide, please, if you wouldn't mind, Andrew. So the civil infrastructure sector has experienced several infrastructure and significant challenges currently, such as the need to decarbonize both our economic infrastructure assets and our transport systems. Essentially, the need to increase the level of social value that investment in economic infrastructure delivers to society, and also the need to increase productivity gains and ultimately improve our industry's track record of successful project and program delivery. So at the tail end of last year, the government published, or through the Infrastructure and Project Authority, published its Transforming Infrastructure Performance Roadmap to 2030. And really what that document does is outlines their vision for how they plan to improve infrastructure performance by prioritizing the needs of society and also using modern digital approaches and technology alongside improved delivery models to achieve them. It calls for a digital by default approach to infrastructure delivery, with both clients and suppliers collaborating to make use of digital technologies to improve productivity, efficiency, and quality. The UK government's net zero strategy was also released last year, and again that calls for reducing the embodied carbon across the infrastructure sector, decarbonising rail and highways, for example, as much as possible, and also increasing the modal shift to active travel. But ultimately, the successful delivery of economic infrastructure is hugely dependent on the procurement, the contracting and commercial approaches chosen. And these are ultimately then dependent on the clarity, consistency and specificity of the requirements, the allocation of risk, and ultimately responsibility across that contract and procurement. So the presence of inconsistent or ambiguous requirements is a significant issue, especially when standard forms of contracts such as the NEC suite of contracts, which specifically deal with ambiguity and consistency and apply very much in a robust fashion the contra pro forentum rule around where an error or an ambiguity or an inconsistency in a requirement is judged in favor of those who didn't produce the requirement. So this can very much result in additional commercial and risk exposure for the parties of the contract, depending on where it lies. So therefore, clear and well-defined requirements are essential elements to successful project and program delivery within the NEC suite of documents and also within the infrastructure sector itself. So the construction playbook, if you just jump back one slide. The UK government published the construction playbook in December 2020, really to set out key policies and guidance for how public works, projects and programs should be assessed, procured and delivered. It included specific policies and guidance referencing and linking to the need for clear requirements. Specifically, an outcome-based approach, which requires the setting of clear and appropriate outcome-based specifications that are designed with the input of industry to drive continuous improvement and innovation. A call to standardized designs and components and interfaces to drive innovation and the adoption of modern methods of construction by both standardizing the aggregation of demand and increasing client capability through the setting of clear requirements for suppliers. And ultimately then creating sustainable win-win contracting arrangements that ultimately incentivize outcomes, improve risk management, and promote the general financial health of the sector. And furthermore, the playbook then places a requirement on all contracting authorities from a government perspective, so central government departments and also arm's-length bodies such as Network Rail or Highways or National Highways, to ultimately adopt these policies and guidance and support the development and use of a consistent structure, rules and language in development of standards and specifications to facilitate a kind of a shared understanding across the supply chain and look to use digital and automated solutions wherever possible. So next slide, please. I think all that very much ties into the benefits that QV Scribe, for example, offers to the market and to clients in terms of ensuring that inconsistency is removed and ambiguities removed from documents and specifications and requirements. So I just want to finish very quickly on a sample case study from, I suppose, the economic infrastructure sector. And that is one you're pretty much, most of you will be familiar with, which is High Speed 2. Latest valuation is 72 to 98 billion. It is ultimately a complex major infrastructure program which spans decades and will need and require significant levels of client and supply chain and stakeholder needs to be defined, captured, verified, delivered, and ultimately assessed as complete in the end. It's a very complex work breakdown structure. You'll see a delivery structure on the right-hand side giving you an idea of some of the major packages, and each one of those kind of clear boxes is a different joint venture between a number of companies or a different company delivering a whole range of different contracts and services. So you have multiple supply chain interfaces across the work packages themselves, and then you have a variety of procurement and contracting models dependent on the work packages, their risk and their value, for example. So having different parties involved in drafting of the requirements and delivery of those requirements means plenty of opportunity for inconsistency and poorly drafted requirements and unclear specifications to result in major cost and time implications for the delivery of HS2. So ultimately, it's clear that requirements management is key for a major program, an economic infrastructure program like this, and the digitalization and the use of AI to ultimately improve the sector's ability to manage and deliver clear requirements and specifications is very much proven, I think, by the fact that the complexity alone cannot be handled by humans. And referring back to the first presentation, that seems to only get worse as we get more and more complex in terms of the infrastructure we try to deliver. So just wanted to finish on that point. Thank you very much, Andrew. And yeah, on to the Q&A if that's ready.
Brilliant, Conor. Thank you very much, and thanks for persisting in the face of some technical difficulties there. It was great to hear from you at the end. Yeah, so let's open the Q&A and get all our panelists back online. We have had some questions through. I can encourage our audience to continue to use the Q&A tab and submit questions. We've got about 20 minutes before we hit our 3 o'clock hard stop. So I'm going to go to the first question we have here. How is product development changing in different sectors with the rapid advancements in technology we are seeing year on year? Jordan, perhaps you'd like to lead us on that.
Sure, happy to. We're seeing dramatic changes, obviously, across all sectors. And I think Simon mentioned something that we're seeing across industries, and that is the rise of systems engineering. What used to be more of almost like a very important, but kind of a niche area, small, is now becoming more and more prevalent. And that's going to continue growing. This systems approach is going to become absolutely critical. Another thing that we're seeing across many different industries is that it almost sounds cliche to say it, but its communication is becoming more and more important. And I think Luke mentioned that. Then one of the important things is really communicating the design intent and making sure everyone understands and everyone is on the same page and everyone is aligned. Because what happens more as things becoming more complex and new kind of technology is being inserted into the workflow, what's happening is these small changes, especially in the early stages of development, compound and get larger and larger and larger and become massive problems, especially when these projects takes years to develop, right? And so making sure you get clarity in front. One of the things we often say is requirements should be as specific as possible, but not more so than that, right? And sometimes if you don't know all the requirements, you shouldn't over-specify. That's as maybe not quite as problem as under-specifying, but that is also a problem. You really want to capture your intent and your knowledge as it exists today.
That's great. Thanks for that, Jordan. Simon, I'm going to go clockwise on my screen. Simon, to you next.
I'd say, it's a really interesting question. Certainly in our fit, you can't react overnight to what else somebody is doing. So it's really important. We have what we call technology roadmaps. Technology roadmaps are looking forward 10 years, whether you're talking at a battery technology roadmap or whether you're looking at a ADAS technology roadmap, which is around automotive autonomous driving, where you're looking at an automotive health roadmap. Whatever those roadmaps are, you have them in advance of you and you pre-develop. So there's a significant amount of pre-development before you start doing the product development. And with that, again, Luke mentioned it, the leadership of those is key. Having your intelligence and your fingers in the pies and knowing what's going out there and not being afraid to see what others are doing. I mentioned disruptors. Not all disruptors will succeed long-term, but they will succeed short-term in making a big impact. And if you can react to that big impact, you have a chance.
Alex, thanks for that, Simon. Alex, up next.
Yeah, I think it's a real challenge, and I think one of the big challenges that we see is for brand new technologies that are moving at pace, there isn't necessarily an accepted route of developing those products. So I guess when you're thinking about your requirements at the start for an accepted product category, it might be that you need to meet this offshore operation standard set by DNV. But if you're developing a technology that isn't captured in that standard, then that can't form part of your requirement. But presumably this product still does have to meet some sort of operational standard. So you're trying to juggle requirements that don't necessarily exist in a kind of written down coherent form, and trying to predict what those standards might be. So and then when they are published eventually, hopefully before your product comes to market, is it what you predicted it might be? And it might not be, and you might have to make rapid changes to your design. So that's a real challenge as technology gathers pace.
Thank you, Alex. Luke, have you got any input on this? Luke, are you with us? Would you like to come in on this?
I'm hoping so. There seems to be times when my internet connection appears to resemble a damp piece of string, so I apologize for that. Let me start talking and gesture frantically if I freeze or you can't hear anything. Yes. I think the question was about how advances of technology have changed this. And At some levels, yes. I mean, there's certainly tools to help in a way that there weren't even when I started my career. It is hugely easier to create representations, digital representations, animations, VR. Heck, a couple of years ago, messing about, I created a VR representation of how I was going to be changing my bathroom. That's something that is inconceivable 5 years ago. And all of that helps get a clear vision of what you're trying to do across. I do, however, think that the fundamentals probably haven't changed. The projects are getting bigger, the projects are getting more complex. Perhaps the issue of coming up with a really clear picture, and when a lot of people say systems engineering, what they really mean is coming up with a really clear picture of what you're going to try and do before you start doing some bit of it. Remains absolutely vital, and it's often it requires bravery to do that, in the sense that you may often know how to get started on 85% of what you're trying to do, and the temptation there is always to give in to the pressure to get started on it. But you'll be really kicking yourself if something in that last 10 or 15% renders the 85% a waste of time. And so in many ways, I think I'm coming around to arguing that the basics are, the same basics as when the Romans tried to build the Colosseum.
Thanks for that, Luke. Connor, thanks, Luke. Connor, are you still with us? Would you like to come in on this?
I am.
Construction sector.
Thanks, Andrew. I suppose from the infrastructure sector, the requirements that, shall we say, take Network Rail or National Highways, for example, those highways or those requirements have been built up over successive decades, and they will be used regularly and developed as they go. So the requirements constantly change, but they're always taking the last set that were successfully used and developing those moving forward. I think the benefit of the new kind of digital approach in AI that we're seeing is that it is helping to, referencing back to Jordan's points in his presentation, it's helping to free up more senior expertise to concentrate on maybe the depth of specific requirements, while more junior engineers can cover and essentially check and adjust those requirements to suit specifics of a project or program much easier. And I suppose it complements the provision of that review process to the point where it does allow you to be a bit more focused.
Thank you for that, Connor. Okay, we're going to move on to the next question now. It's coming from Greg Martin. Do each of your companies employ a formal requirements process, or is it more ad hoc? And then in brackets on the users to ensure requirements are written properly, possibly with the help of QB Scribe. Alex, I'm going to come to you first on this and then move around the houses then, if you'd like to take that away.
It'll probably be quite a quick answer because I guess not being a company that develops their own products necessarily, we're usually just playing a supporting role in other companies developing their products. So we would usually feed into a requirements gathering process using our kind of knowledge of the offshore wind industry. And I would say that we come across a real mix in terms of companies that have developed a number of products in the past who have more formalized procedures that they are comfortable with and that they follow very closely, compared to brand new startups who this might be their first technology that they're developing, and it can be more chaotic, shall we say. So I guess that's probably on the more ad hoc end of things.
Simon, what's it look like at Bentley? What's the
requirement? So, yes, we have a formal process. We're part of a big group that the software is developed by another provider. They have a specific tool. We input into that tool. And that's absolutely critical because you can't afford to lose the requirements. They can't be written down on someone's pad or piece of paper or email. They need to be embedded, because what you need to remember with the requirements, particularly in our sector, which is a short-term sector, It's 4 years. So when you come to validate the product after 4 years, you might have forgotten what the requirements were you set out on the start. So the importance of that formal recording process is critical to us.
Thanks for that, Simon. Jordan, would you like to come in on this? Obviously, you're the solutions provider rather than sort of. But do you, when you're, how does this relate to QRA?
Yeah, obviously it relates very critically. It's part of our core business proposition. So I am biased on this, but I can't tell you a little bit about what we're seeing in the companies that are successful and not successful. And the ones that really, so the short answer is yes, successful companies have a process in place, right? Formal is a funny word. I'm not sure how to interpret formal, but they have the right level of detail in their process. And really, it's more of a mindset for the most successful companies. They treat the requirements phase in the very initial stage, the design and the pre-design stage, the intent gathering stage, as part of their engineering process, right? So they incorporate, just like as you write code, you would never write a complex piece of software without having a code repository, right? It doesn't make any sense. You will fail if you do that. Those that integrate this directly into their engineering process, so they have this kind of digital thread from the requirements right down to testing and deployment and the whole lifecycle management of the product. Those are the ones that are successful. So it's not sort of one separate thing that sits on its own. It's integrated and treated as part of the engineering process.
Great. Thanks for that, Jordan. Luke, would you like to come in? Luke, are you there?
Hello there. Yes, I'm here.
Would you like to come in on this, please?
So yes, we do have a formal process, and it's particularly, how requirements should be formulated, how they should be numbered, captured, a variety of tools for ensuring traceability, that kind of thing. The other important thing I think to get right is the balance between the desire for pretty much every engineer to be involved in the requirements writing process. Writing requirements, management, medical devices development engineer, you really ought to have a decent understanding of it. But at the same time, we have a number of design control engineers who are sort of strongly specialized and carry the company knowledge as to ensure get a level of uniformity, consistency in the style and depth of requirements. And so you need to grow that expertise whilst at the same time not letting people think, oh, it's requirements, it's boring, I'll get them to do it. You need to own your requirements. You need people, I believe, to facilitate getting them correct. You do need a process and a tool set for managing them effectively. Otherwise, it rapidly becomes a thankless task.
Thanks, Luke. Connor, are you still there? Would you like to come in on this?
And I have no idea how much of that you heard.
All of it.
I'm not eating nice.
Getting accosted by my 4-year-old here. Connor, Connor, are you still with us, Connor?
I am. Thanks, Andrew.
Would you like to come in on that?
Yes, no problem. I suppose from WSP's perspective, we're an engineering consultancy, and we support clients across a huge range of sectors and markets. And I suppose it varies depending on which part of the business you sit in. We do have a formalized process for drafting of requirements, but again, that the application of that can vary depending on a specific client's requirements. I know that, for example, the rail industry is very, very heavy on system engineering and the approach to requirements definition and delivery, whereas some of the more local government kind of maintenance contracts may not be as specific. So it does very much depend, I suppose, where you sit within our business, whether you would be hands-on day-to-day with requirements development, or whether you would be looking to another part of the business to support your particular project or program.
That's great. Thank you so much for that, Connor. We are coming up to 3 o'clock and we do have a hard stop there. So I don't think we actually have any more time. We had loads of questions through. Thank you so much for our audience participation. We've covered loads of ground. I think it's been a fascinating conversation. I'd like to thank once again our partner for this session, QRA, as well as the individual panelists who've been extremely generous with both their time and their knowledge. A very big thanks to all of you. I'd like lastly to thank our audience, everyone who's tuned in live or is watching back on demand. We hope you found it enlightening and engaging, and that you join us again in the future for more online discussions. But for now, that is all we have time for. Take care and goodbye. Thanks a lot, guys. Thank you very much.
Thank you, everybody.
Thanks very much.
Cheers.
Thanks, everyone. Cheers.
Thank you very much.